Hey everybody, let's give this problem a try. So there's a truck. So let me just have a little truck here. And then let's say this is the front. So the free body diagram, let's say there's weight. The tires are touching the concrete ground, the road. So there's a normal force here and a normal force here. And then, like if you step on the gas, the truck is going to go this way, right? So there's a force forward, but then that comes because the drive wheels are turning, and then there's got to be friction between the tires and the road. So that's going to be a force this way, and it's going to be friction. If you just look at the free body diagram, right, in the horizontal direction, there's a net force going toward the left, which is going to cause the truck to accelerate to the left. But is this static friction or kinetic friction? So let me bring up a little demo here. Okay, so let's say I have this roll of tape. Imagine that's the wheel, and then let's say my hand is the ground, and then I put a little like dot on the wheel and a dot on my hand. So look, imagine the dot on the roll of tape is a molecule of rubber in the tire, and the dot on my hand is like a molecule of concrete in the road. See how they don't slide with respect to each other when the tire is rolling, as opposed to this. Right, so this is kinetic friction when there's slipping. But when there's not slipping, look. So rolling without slipping is actually static friction, whereas slipping is kinetic friction. So let's assume that the tire is rolling without slipping, which makes it static friction. Right, so this is actually static friction here. And okay, so there's normal force. So there's our free body diagram. And if we pick coordinates, right, let's write Newton's second law. And y direction minus the weight. Okay, and there's only motion in the x direction, horizontally. There's no motion vertically. So in this case, this is 0, ay is 0. Okay, and then what do we know about friction? We know that static friction is less than or equal to mu s times n. So that's the coefficient of static friction. That's the normal force. We were told that half the weight is supported by its drive wheels. So this is half of the weight. So this has got to be the other half of the weight. So I'll just say that those are the same magnitude. So N1 and N2 are the same magnitude. I'll just call it N. So from this equation right here already, 2N equals W, N equals 1/2 of the weight, which is what it said right here. And then mg, and we know the mass right here. And this normal force goes right here. Now let's take a look at this and kind of use our critical thinking skills. The static friction is less than or equal to this amount. So at most, max, it's equal to this. So that's what we can put here, right? So at most, that goes here, and that's what we're looking for, maximum, right, at most. So let's substitute everything. So I'll put it here, right? So at most, mu s N equals MAX. N is half of the weight, so I'll just put it right here. Half of the weight. And then mass is non-zero, so then we have the acceleration is 1/2 mu s times g. There we go. And then I just copied this table straight out of the book, so we got, what is it? Here. Let's use that value. Static friction. Okay, let's move on to part B. So now we have a metal cabinet on the wooden bed. Okay, so let me draw it like that. So here's the truck. And then there's a metal cabinet like this. So for the metal cabinet, free body diagram, right, the truck was accelerating this way. So then which way is the friction? If you're the metal cabinet, right, the truck is here going this way. So there's got to be friction this way. Okay, and then the cabinet has, right, it's in contact with the truck bed, so there's a normal force, normal to the truck bed, and then the cabinet has weight. Okay, so here's the free body diagram of the cabinet. I will pick coordinates. Okay, and then the x direction. The y direction. Again, the acceleration is only happening horizontally, nothing vertically. So in this case, AY is 0. Okay, now the question, is this static friction or kinetic friction? So we have to use our critical thinking skills. If there is enough friction, then it won't slip. If not enough, then it will slip. Right? So that sounds simple, but that's how we kind of have to break it down. So at most, right, max, we have this much static friction. At most. If it's not enough static friction, then it will be kinetic friction and then it will slip. So let's take a look at this, or I'll phrase it this way. Who wins? This side of the equation or this side of the equation? So let's focus here, right? The left side of the equation is this. The right side of the equation is this. So who wins this battle? This or this? Which is more? Is there enough static friction to overcome this mass times acceleration? If yes, so is this true? I'll just leave it like this. Is this true? Is there enough static friction to overcome this? If there is, then it won't slip. If not, it will slip. And then that's it. And then N minus mg equals 0. So N equals mg. And then mass is non-zero. So let's just divide both sides. And there we go. This is what we're looking for. And that, of course, depends on the answer we got in part A, which is right here. Right here. So for part A, AX equals 1/2 mu s times g. AX was 1/2, let me look over here, right? 1/2 mu s times g. Oh, let's be careful though. This is for wood and metal. This one here is for rubber on concrete. Not the same value. Okay, so on this side it was 1/2 mu s times g, but this was for wood, metal. This is for rubber, concrete. Okay, and then you can see how this cancels on both sides. Okay, so then that's all you have to do is look up the value. Wood, metal, that was, where is it? Oh, here, 0.5. And then rubber on concrete was 1. Okay, so 0.5, and this was 1. Is this true? Yes, barely yes. So, but yes. So there is enough friction to keep it from slipping. So that's the answer for part B. Is it going to slip? Nope, it's fine. It's not going to slip. Okay, now part C. If you have 4-wheel drive, can I just recycle my free body diagram here? The only difference now is there's going to be friction here as well. Right, the front wheels and the rear wheels both have a driving force. So then it looks like this. So that if when we write out Newton's second law, there are 2 of them. So 2 Fs. And then in the y direction, everything is the same. So the only thing that changes is we have the acceleration. 2Fs is at most mu s times n, at most. And then n was half of the weight. And then cancel, cancel. So then AX equals, see the 2 and the 1/2 cancel, mu s times g. So it's just exactly double of our first answer. So with 4-wheel drive now we have double the acceleration. So then if we do this part again, the difference here is this will be double. So instead of 1/2, 1. And then look, this is no longer true. There is not enough static friction to prevent the cabinet from slipping off of the bed of the truck. So it will slip. Okay, so that was kind of a lot of information. So just let me know if it makes sense. If you need more help, just let me know in the forum, and I'll see you on the next video.